All right, we're going to go over this foldable here, this pink little folder you have. Extend that. These are kind of now doing some application with Trig. So we're just going to go to a tab at a time. This first part is going to kind of address the first two tabs. So if you open up the top part here, okay, this is the cover, this is the tab. So underneath, we're going to look at some example problems, and this is what you've been focusing on. And so, so far the results are looking good online with the skill check and even with um, the decimal self-checking. So sine, you have to remember, is opposite over hypotenuse. Cosine is adjacent. I should probably say cosine. Adjacent over hypotenuse. And this cosine of A is your angle, the reference angle. And then tangent of A is opposite over adjacent. So we're going to use those ratios to just give the ratio in this model problem here. We're going to make sure we reduce that. So now, let me just get my font right. Here, we're going to go here, hold up, and we're going there. All right. So in these examples here, we're doing the sine, the trig ratio for angle R. Over here, like sine at R, cosine R. So in previous examples, I said circle your reference angle, and then you want to label the parts. Well, opposite the right angle is always a hypotenuse, so I'm just going to put an H there. Across or opposite the reference angle, this angle R that I circle, this is the opposite side, so I'm going to put an O here, okay? And right next to, basically the side that makes the angle, that's the adjacent side. I'm going to put the A there. So for us to do the sine of sine of R, the ratio is looking for the opposite over the hypotenuse. So the opposite side right here is 10, I'm going to put an equal sign, over the hypotenuse, which is 26. The thing we have to remember is this can be reduced. We can simplify. You can use your calculator to do that, but they have basically 2 in common. So this is 5 over 13. And whenever you give your answer, you're going to give the simplified ratio. Okay. So if we're doing the cosine of R, same reference angle, cosine is just A over adjacent, A over adjacent side over the hypotenuse, A for adjacent, sorry. And your adjacent side where my A is the 24, okay, over our hypotenuse, which is 26. Again, we can reduce this to 12 over 13. Okay, we just cut it by half. And then tangent, the tangent ratio is the opposite side over the adjacent. Okay, O over A. And the opposite again is the 10. The adjacent is the 24. Again, we're reducing this until cut it divided by 2. This would be 5 over 12. Okay. So this is what you're really focusing on, the maze that you did, along with your little riddle and your skills check. Now, some practice problems, some more kind of just in depth, showing the understanding and relationship, is we're going to still do the same thing, but I just want you to recognize on these practice problems, our reference angle could change. So here we're doing sine of J. So I'm going to circle J, and I'm still going to remember that the sine, yeah, I got that right. The sine is the opposite over the hypotenuse. So if J is my reference angle, the opposite side is this KL, which is 3, over the hypotenuse, which is 9, which this can reduce to 1/3. Okay. Now, cosine of L. So now I'm doing a different reference angle, which is L. Cosine is dealing with adjacent over hypotenuse. The adjacent now is also the 3. That would be the adjacent side. So this is 3 over 9, which is 1/3. Okay. Now, tangent of J, tangent is still your opposite over hypotenuse. I don't know if you can see that. Okay, so opposite of J is the 3. The hypotenuse, I mean, not opposite of hypotenuse, opposite of adjacent, sorry. Opposite is the 3, so 3 is on the top. That's the opposite side. The adjacent is the 6 root 2. Okay, and you cannot, I'm going to put a star here. We cannot leave it like this because we have a radical at the bottom. So we have to rationalize that, meaning you're going to, let me change this font. I change the top and bottom by root 2. Okay, so this will leave me with 3 root 2 over 12. And then I'm just going to make a little note that this can be reduced. 3 over 12 can be reduced. So the final answer is root 2 over 4. Okay. Hopefully you can see that. So if I'm doing the sine of L, sine is opposite. So the opposite of L is the 6. We're doing opposite of hypotenuse. Opposite is the 6 root 2 over the hypotenuse, which is 9. And then just so we recognize 6 and 9 are outside, those can be reduced. So this would turn into, we have 3 in common, so this would be, I'm going to come down here, 2 root 2 over 3. And we can leave it like that because we don't have a radical on the bottom. Now, as for determining which angle is when given the trig ratio, so you're given, you're going to use the given to determine which angle. So if I'm given the ratio sine of A, remember the sine is the comparison of the opposite side over the hypotenuse side. So that means the opposite needs to be the 4. Okay. Well, we don't have any 4s, but we know what the hypotenuse is. It's 10. Okay. So if I have 10, but it got reduced to 5, right? So what did I have to do to get that? Basically, I have to double that. So if I double the 4, that would make this 8. So that means 8 is the opposite side. So to get the angle I'm looking across, that means our answer is angle A is angle 1. That's what they're trying us to determine. Which angle would be angle A? It would be angle 1 here. Now, on a problem like 6, the cosine of 0.6, this is 6/10 basically. I'm just going to write that as 6 over 10. And just remember, cosine is comparing the adjacent over the hypotenuse. Well, we already know this is the hypotenuse. Which angle would be adjacent to 6? Again, that is angle 1. So this is kind of good mixture of using ratios. I don't think you had to find the angle on your skill check, but you did have to reduce your ratio. So from using these ratios, we're now going to be able to find a missing side. So this is the tab we're going to do next. Okay. And I'm going to go through the steps on how you're going to do that. Hold on just a second. All right, so in order to do this, we have to remember the little acronym SOHCAHTOA. Sine is opposite of hypotenuse. SOHCAH is your adjacent over hypotenuse. TOA, opposite over adjacent. Okay. We're going to use this to set up and solve to the nearest 10. So the way you do this, you always have to have a reference angle, a given angle. And if you look here, I'm going to try that. Our reference angle is the 32. Okay. I circle that angle and then I label the given sides. So if I look from this 32, this X is my opposite, so that's an O. And this 13 is the adjacent side, so that's an A. So because I have an O and A, this matches tangent. So we're going to write a proportion, an equation with tangent. So tangent of angle A, so this is how we write it. We go tangent of 32, the angle, degrees, is equal the opposite, which is the X, over the adjacent, which is 13. Now, to solve this, I'm going to show you a shortcut, but basically, the easiest way to do this is you want to create a proportion. So we're going to put this over 1. 2 ratios as a proportion. 2 ratios that are equal to each other. And then we are going to cross multiply. Well, 1 times x is just x. And here, when we cross multiply this is saying 13 times that tangent of 32, okay? You have to keep the tangent and the angle degrees together. You cannot multiply the 13, because this is degrees and this is segment. This is measurement. This could be centimeters or inches or something. You can't mix those up. Now, there's a key thing or key component you have to do to make sure you can do this in the calculator, because we're not going to use trig on our calculator to solve this. The thing that you have to recognize first, and I will constantly remind you of this, is that your calculator is in the correct mode. We are looking at angle measurements that are degrees, so we need to make sure our calculator is in that mode. And to do that, you hit this mode button right here, and then if you look down, right now it's in normal. If you go down right here where it says radian, and then to the right of that it says degree. See, my calculator is not in degree mode right now. So what I'm going to have to do is hit enter, so that is highlighted, okay? All right, so we're just going to get out of that. All right, so on your calculator down here, you have the sine, cosine, and tangent, okay? Since we knew, or since we just solved, I think it was this one, yeah. To get x, we have to do 13 times the tangent of 32, and we're going to, it says right here, to the nearest 10, okay? So what we're going to have to do on the calculator aspect is, let me get to my calculator, is type in 13, then hit times, and then we're doing tangent of 32 degrees, okay? Hit enter, and we're going to round this to the nearest 10, so this is just going to be 8.1, okay? So the answer x is approximately 8.1. Probably should have done a different color, but that's where we are, okay? There we go. All right, so let's try the steps again. First thing you do is you circle the given angle. So this is 37, or we're talking about angle B. They're the same thing, okay? Then we label our parts. The 11 in reference to this angle is the adjacent part, and the x is across from the 90 degrees, so that's hypotenuse. So right off the back, I'm looking at A and H, so this means I'm doing cosine. So we are going to write the cosine of 37 equals the adjacent side, which is 11 over x. And we're going to put this over 1 so we can cross multiply. That's what we want here. Now this one's slightly different than the one before. When I do 1 times 11, that's going to give me 11. This is going to equal, and then when I cross multiply this variable times the trig, you're going to write x times the cosine of 37. Now, to solve for x, to get this x variable by itself, you're going to have to divide both sides by the cosine of 37. Okay? Probably should have moved up, but by doing that, these cancel. Okay? Now I got my x variable by itself. So x really is equal to 11 divided by the cosine of 37. Sorry about that. So we have to go to our calculator, and we have to do 11, then divided by the cosine 37. We're going to close the parentheses. I think you don't have to close the parentheses, so it'll work. Hit enter, and we're going to round to the nearest 10th. Since there is 7 right here, this is not going to be 13.8. Okay. So x, actually, x here is approximately 13.8 units. Okay. So the difference between, I just want to talk to these two examples before we move on, and I can show you a shortcut. So the difference is where the variable is. Okay. In example 1, the variable was on top of the ratio. Here, you see that? Where in example 2, the variable is on the bottom. So whenever the variable's on the bottom, you're going to always end up dividing to solve. Whenever the variable's on the top, you're going to always multiply to solve. And I can go through this in this practice problem, all right? So let's say I want to find, I'm going to extend this page just slightly. I want to find the y first. We can go in order. Let's find the x. So this is my angle, okay? And if I'm finding x, this would be opposite, and this would be the adjacent. Do they have to write what trig function deals with an O and an A, opposite and adjacent? That is tangent. So we're doing tangent of 50 degrees equals the opposite, the x, over the adjacent, which is 5. So the x is on top. Because the x is on top, let me just do this. So on top, you multiply. I'm just going to abbreviate that. So basically, I can go straight to showing that. Or you can go back to putting it over 1 and cross multiply. It doesn't matter. Okay, it's up to what you feel comfortable with. But this is x equals 5 times the tangent of 50. Okay, to get that answer. So we have to go to our calculator. We have to type in 5 times the tangent of 50. Hit enter, round to the nearest tenth. This is actually going to round up to 6 because we have a 5 here, and that's going to change both of them. So this is x is approximately 6. Okay. Now to do our y, right? The y is the hypotenuse. So I have the hypotenuse and I have this adjacent. So always use a number and a variable to get to a trig. So that means this is cosine. So this would be the cosine of 50 equals the adjacent, the 5 over y. So this is what I was talking about. Now here, the variable's on the bottom. Okay. So when it's on the bottom, you're going to divide. Or you can switch and divide. Let's put divide here. So this is what I mean by switch and divide. We're going to take this cosine of 50 and put it where the y is. I'm now going to put the y on the other side of the equal sign. So this is y equals 5 divided by the cosine of 50. Okay. And now we're putting that in the calculator. So practice doing that, guys. 5 divided by the cosine of 50. And we get 7.8. Okay. This is approximately 7.8. All right. So I want you to try the practice problems on Excel to kind of check your understanding with finding missing sides of right triangles using trig. So we're going to move on to some practice, or eventually going to move on part 2 of this video. So that takes care of that one. Thank you.